All right. So I'm going to spend a couple minutes here talking about the atomic structure. So the beginning of our unit begins talking about a guy named John Dalton. Basically, John Dalton was an English chemist, and people generally refer to him as like the modern father of atomic theory. And the reason for that is because John Dalton had interest in meteorology and gases, and basically that led him to follow in the path of a guy named Antoine Lavoisier. Now, Antoine Lavoisier, for lack of taking more time, his big thing was this idea of the law of conservation of mass, meaning that when in a chemical reaction, matter is neither created nor destroyed. Now, he worked also in contact with a guy named, his first name I think is Joseph Proust. And basically, he came up with this idea of this thing called the law of definite proportions. Law of definite proportions basically says that you can have elements in a compound that combine in different ways, and those different ratios will give you different proportions of their mass. And so Dalton comes along and he says, okay, we've got these atoms, and we think that they create and make up things such as, my pen that I have right here. And basically what he says is he comes up with what's called, Dalton's 4 postulates of atomic theory. And those 4 postulates are basically this, so that elements are composed of atoms that are indivisible and indestructible. Okay? So that means that we could not break them apart. Now, we've advanced our knowledge of subatomic particles to the point where we can undergo nuclear reactions. But at this time, in the 1800s, this was pretty novel thinking. And for the most part, we're not undergoing nuclear reactions in nature or out in the natural world. So for the most part, they are indivisible and they are indestructible. The second thing that they would say is that if you have an element and you look at an atom of gold, for instance, and you look at another atom of gold, the 2 atoms are identical. They're the same. And that makes sense, doesn't it? And they would have to have the same mass, he said as well. Now, he's a little bit wrong because eventually we're going to talk about something called isotopes. But again, in 1800, this was novel thinking. And it kind of makes sense, right? That, if I was looking at a chunk of iron, all the different atoms in there would be iron atoms. Kind of to me. The third thing is that, okay, if I was, this one's another duh one to me, is that if I looked at, 2 different elements, like if I looked at gold and aluminum, and I looked at their atoms would be different and have different masses. Well, yeah, because that one's gold and this one's aluminum, right? So the fact of the matter is that's pretty true as well. And then the fourth one's a pretty important one because it talks about compounds. And basically what he says you can take these atoms and you can join them together and make different things. So you could take 2 atoms or 3 atoms, and you can make them in different ratios, 1 to 2, 2 to 3, that kind of thing. I mean, if you think about it, like something like water, 2 hydrogens to 1 oxygen. But the second you take 2 hydrogens and put it with 2 oxygens, you have an entirely different compound known as hydrogen peroxide. Or how about carbon monoxide, 1 carbon, 1 oxygen, that's lethal and deadly to us as human beings. And CO2, carbon dioxide, which is a part of cellular respiration, and I just breathed a bunch all over you. So that was John Dalton's big thing, and we've updated it over time. We've come up with this idea of isotopes, but it's still pretty true to this day, and those are his 4 postulates. So elements are composed of atoms. They're indestructible and indivisible. That all atoms of the same element are alike. Atoms of different elements are different. And that number 4, we can take them and make compounds out of them. And that is John Dalton. All right, just to add real quickly to the Dalton idea. You're asked at the bottom of your page to talk about his 4 points, so I just went over those. But you're also asked to talk about how the atomic theory, Dalton's, differs from the modern atomic theory. Well, there's going to be 2 major ideas there. Okay, the first of which is that idea that nuclear chemistry and nuclear reactions can modify nuclei, meaning that atoms can be destroyed and changed, so they're not indivisible and they're not indestructible. And then the second thing is this idea that isotopes exist. The mass of every single type of carbon isn't exactly the same, actually, because there's carbon version 12, carbon version 14, etc., etc. Now, at their core, they're pretty much the same, but you have an extra neutron. Actually, you have two extra neutrons in this case, and they do have some mass. So because of that, his idea that all the masses are the same, it's not exactly accurate. But again, it's pretty darn close. It's pretty darn strong. And Dalton's theory of atomic structure for the 1800s was pretty ingenious.